Welcome back to the Design for Injection Molding course. This is Lecture 3 and today we're diving into one of the trickiest challenges in injection molding undercuts. Injection molding is a fast and efficient way to make lots of identical plastic parts. Imagine pouring melted plastic into a waffle iron. That's basically injection molding. The melted plastic cools and hardens in the mold, taking on its shape. This process is used to create all sorts of everyday objects. Think about your phone case, the buttons on your keyboard, or even parts of your car. All of these are likely made using injection molding. It's a versatile and widely used manufacturing method. Injection molding is popular because it's fast and can produce complex shapes. Once the mold is made, making thousands of parts is quick and inexpensive. This makes it ideal for mass production. However, there are some design limitations to consider. One common challenge is dealing with undercuts. These design features allow for complex shapes but can add cost and complexity to manufacturing. We'll break down what undercuts are, why they're challenging, and how to design them smartly using techniques like side actions, lifters, and clever design modifications. Let's get started. An undercut is any feature on a part that prevents it from being ejected straight out of the mold. Think of a bottle. The top part is wider than the neck, creating an undercut. These undercuts can be internal or external. An internal undercut is like the inside of a bottle. An external undercut is like the lip on a bucket. Both types create challenges for mold making. Undercuts are important to understand because they add complexity to the molding process. We'll delve deeper into why undercuts present such challenges. Undercuts make it tricky to remove the molded part without damaging it. If a simple two-part mold is used, the part will get stuck on the undercut. This is where special techniques and mechanisms come in. We need ways to create molds that can accommodate these undercuts. These special techniques often mean more complex and expensive molds. Simple molds are easy and cheap to make, but molds for parts with undercuts need extra moving parts. Designers try to minimize undercuts to keep costs down. Sometimes a small change in the design can make a big difference in cost. We'll discuss some of these clever designs. Techniques for handling undercuts, side actions, lifters, and collapsible cores. Let's look at some common solutions for dealing with undercuts. Side actions. Imagine a small door built into the side of the mold. This door, or side action, moves out of the way when the part is ejected. Once the part is out, the side action closes back up, ready for the next shot. Lifters. Picture a small elevator inside the mold. This lifter moves upward when the mold opens, pulling the part away from the undercut. Lifters are great for internal undercuts. Collapsible cores. These are like special cores that can shrink or collapse inwards. This allows the part to be removed without getting stuck. Think of it like deflating an air mattress to make it easier to store. These techniques allow us to create complex parts with undercuts. However, they do add to the cost and complexity of the mold. Design tips for cost-effective undercuts. Here are some handy tips to reduce the headache and cost of undercuts. Can you eliminate it? The easiest undercut is the one that doesn't exist. See if you can achieve the same function without the undercut. Maybe a slight change in shape will do the trick. Modify the angle. Sometimes a small change in the angle of the undercut can make a big difference. A shallower angle might allow the part to release more easily. Parting line adjustments. Slight modifications to parting lines can eliminate unnecessary undercuts. Redesign snap fits and hooks. Replace deep undercuts with flexible features to avoid expensive mold actions. Consider two-part assemblies. Instead of a complex one-piece design, breaking it into two simpler parts can reduce tooling costs. By keeping these tips in mind during the design phase, you can save yourself time and money down the road. A real-world example. Optimizing undercuts in a phone case design. Let's imagine we're designing a phone case. To provide a secure grip, we want the sides of the case to have a textured pattern, creating undercuts. Initially, the design called for a complex pattern across the entire side, requiring multiple side actions. This would have made the mold very expensive. By strategically placing the textured pattern only on certain areas of the sides, we were able to significantly reduce the number of side actions required. This simplified the mold design and lowered the production cost. This example highlights how small design changes can have a big impact on cost and manufacturability. Understanding undercuts can help you optimize your design for efficient and cost-effective production. Mastering undercuts is just one part of design for injection molding. For full training on injection molding, visit courses.3ddfm.com and level up your design skills. Need expert consulting to improve your injection molded product designs? BP Nell Consulting offers specialized design reviews, training, and design for manufacturing (DFM) solutions. Visit 3ddfm.com to learn more. Like, subscribe, and hit the bell icon so you don't miss our next lesson on sheet metal fabrication. See you in the next lesson.